Hello everyone, I'm Paul and today we're solving problem 1751, maximum number of events that can be attended to. This is a hard interval problem and here observation is key. So I will show you how to solve this step by step. We're given an array of events where each event has a start day, end day, and value. And we are also given an integer k, which represents the maximum number of events that we can attend. And every time we attend one event, we get the corresponding value. And our job here is to return the maximum sum of values that we can receive by attending events. Of course, we can only attend one event at a time. And if we choose to attend one event, we have to attend the entire event. This is very important. Now let's say we have these events and k is 2. Here you can see the visual representation of the events. For example, event at index 0 is here. It goes from day 1 to day 2 and it has a value of 4. Now given that k is 2, we can attend 2 events as maximum. Here the solution is to attend event 0 and then event 1. The sum of 4 and 3 is 7, so we return 7. Now given that we decide to attend this event at index 0, we can't attend this event at index 2. Because remember, once we decide to attend an event, we need to attend the entire event. Now let's say we are here at event 0 and here we have two choices. We can take this event or not take this event. Now if we decide to take this event, the result is currently 4 and we need to skip up to day 3 because remember we need to attend the entire event. If we decide to not take this event, the result is still 0 and we move to day 2. So each of these paths open sort of like a new universe. If we decide to take this in this universe, then we can take this. This is the winner path. If we decide to not take this, now we are here and now we can decide to take this or not take this. So from here we have two more choices. So we can explore these branches carrying a state with us and remember the result for each branch. And this is dynamic programming. And here we need two things for the state. We need to know in which event are we standing and how many events can we take at every point. So we will carry an index and a count for the remaining events. Now let's say we're here at event 0 and we decide to take this event. From here we need to move up to the beginning of the next event. Now the question is, how can we get the beginning for the next event from this event efficiently? Because here we have these events one next to the other. But it might be the case that we have a very big gap here in between. So we need to find an efficient way to go from the end of this event to the beginning of this event. And here is where we can use binary search. And remember, in order to do binary search, we need to sort the array. This is a requirement for binary search. So the approach for this will be the following. Here we have the events in sorted order by the first element. And down here we have the visual representation of this. And with this in mind, we can start our decision tree with 0 as the result and index 0, meaning we start from the first event and we can attend k events up to this moment, so we put a 2 here. Now remember, here we have two choices. We can take or not take the event. Now if we decide to take this event, now the result is 4 and we need to move from the end of this event up to the next possible event. in this case is event 2, meaning this. So here we move from index 0 to index 2, and given that we attended this event, the current amount of events is 1. Now let's go with the binary search part. We are moving from this event up to the closest event after the end of this event. And here we can do something very clever. First, we will store the start day for every event in an array. Remember, this is already in sorted order. So these are the start days for every event. And from this, we can run a binary search to see where are we placing the end day for the current event, because this event ends here. So we need to run a binary search with this value on the start days to know when is the next event. So the question is, if we had to place this end day in the start days, in which index should we place this? So we run a binary search on the array with every start day. The left pointer is here, right pointer is here, and the mid pointer is here. Our target is 2. First, the value at the mid pointer equals to the target, so we move the left pointer to mid plus 1. Now left equals to right, so we return left, which is 2. Just to be clear, here are the indices. So we return this index. So this is how we go from events at 0 to events at 2. Now if we decide to not take this event, the result is still 0. We go from event at index 0 to event at index 1, and we still have 2 events to take as a maximum. Now we are at event 2, meaning here, and we can decide to take or not take this event. If we take this, now the result is 4 plus 3, meaning 7, and we are at the end of the array, meaning we are here, so we are at index 3, and the count, meaning the remaining events we can take, is 0 right now. If we decide to not take this event, the result will be 4. We would be at the end of the array also, so this is 3, and the remaining events will be 1. If we decide to take event at index 1, next the result is 1. 0 plus 1 is 1. We are at the end of the array, so we are at index 3, and we have 2 minus 1 events to take, so we have 1 remaining event to take. If we decide to not take this event, we have a result of 0. Now we are at index 2, meaning 1 plus 1. We still have 2 remaining events to take. Now here we still have events to take, and the current index is still in bounds, so we can continue here. We can decide to take this event at index 2 or not take this event. If we decide to take this, the current result is 3. Now we move to the end of the array, meaning index 3, and the remaining events to take are 2 minus 1, meaning 1. Finally, if we decide to not take this, the result is 0. Now we are at the end of the array, meaning at index 3, and the remaining events are 2. Now for every leave, we are either at the end of the array or we are out of events to take. For example, here we see both. We are at index 3 and the events to take are 0. And in every other leaf, we are at the end of the array. So this is our base case, and we need to return the maximum among all of these results. and this is the maximum, so we return 7. What this means is this is the winner path, meaning we need to take this event and then this event. Time complexity for this approach will be big O of n times k times log n, where n times k is the required state for our DP and log n is the required complexity for the binary search. And space complexity will be big O of n times k, because we are caching this DP and we are building the starts array. So now let's go with the code and hopefully you will get the idea. First, n equals the length of the events, and now we need to sort these events by the first element, so events.sort. And now we are building the array for starting days only, so we will call this starts. This is an array, and we will take s for s in events. Now we can create our DP function. This will take a state with 2 arguments, an index and a count. Remember, this index is for events. And now we will set our base case. If the current index is out of bounds, or if we are out of events, meaning if we can't take any more events, we need to return 0. So if I equals n or count equals 0, we return 0. Now we need to look for the next event. So we'll set a next pointer here, we'll call this next, and we need to run a binary search. Remember this. In Python we can use bisect, and more specifically here we need to use bisect right. And we'll run this on the array starts, and the target is events at I1, meaning the end day of the current event. This is the target. And now remember, we have 2 choices. We can either take the current event or not take the current event. If we decide to not take this event, we call DP with I+1 and the current count. And if we decide to take this event, we need to call DP with the next pointer, and we need to subtract 1 from count because we are taking 1 event right now, and we need to add the value for the current event. So we add events at I2. And what we want is the maximum value among all of this. So we return this. And down here we need to return a call to DP with index 0 and k events. And finally, remember, we need to cache this entire thing. So this is it for the code. Now let's submit this and see if it works. As you can see, this works and it's efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.